All right, boys and girls, this is going to be helpful with page 80 and 81, which is your homework this weekend. Uh, just a little bit of an explanation. The other day, we were given patterns. We were given arithmetic sequences, and we were asked to find the fifth term, the sixth term, or any term. And we were able to use, right here is the arithmetic formula. We have the first term plus what's happening every time. It's going plus 4, and then times n minus 1. So what we did the other day was if we want to know the fifth term, you could just plug in a 5. 5 minus 1 times 4 plus 14, and you would get the fifth term would actually be a 30. Well, page 80 and 81 are a little bit, is very similar to that. We're going to still deal with arithmetic sequences and only arithmetic sequences. But in page 80 and 81, this isn't page 80 and 81, but this is like it. We're given that we have arithmetic tables. So we know that this table is based on an arithmetic formula, but there's actual gaps in the table. So we're not quite sure what we know it's adding because it goes from 3 to 12, but we don't actually know what it's adding. So what I wanted to show you is a strategy that you can use if for some reason you have gaps in the table and you need to fill in the missing terms. Well, because we know this is an arithmetic sequence, because it would say that, we can actually use the arithmetic formula. Because what we know is we can actually plug every single term in here except for the d, which is the distance, the common ratio. We actually know one of our answers right here. We have that our answer is 12 when the term number is 3. So you can see I plugged in a 3 for the term number, and the answer is 12 because it's something that we know. We also know the first term right here. We got it as a 3. So I plugged that in. And you'll notice you have an equation where there's only one variable that you don't have. And you can actually now solve for this. If you distribute your d to both the 3 and the negative 1, you get 3d minus d, which simplifies to 2d. And then from here, I can just solve the equation. 12 equals 3 plus 2d. I subtract 3 on both sides. I get this. And then to solve for d, I divide by 2 on both sides, which leaves me with 9 over 2, or 4.5. Well, this helps me now know that every time my common ratio is plus 4.5. And I could fill in my missing term by doing 3 plus 4.5, which is 7.5. And to double check it, if I add 4.5 again, I will end up with the 12 I was supposed to have. So here's another example of this. And again, please pause and go back if you need to. Here are two gaps. Well, again, if I knew that this was an arithmetic sequence, I can use the arithmetic formula. So what I did was I took the first term, which was negative 2, right here. I found two x's and y's that I didn't know. I knew that on the fourth term, so I plugged in a 4 for the term. You end up with 26. And then I solved my equation for d. I distributed the d. I combined the d terms. I added 2 to both sides, and I got 9.3 repeating, which is, it's easier to use the fraction because you can't put 0.3 repeating into your calculator. So 28 over 3 would be fine. So now I know that from every single y value, every time the x goes up, you're adding 28 thirds. So to get the next term, I would take negative 2 plus 28 thirds. And then I would take that result and add 28 thirds. And if I do it one more time, you should end up with 26. Here's another one that you can do. And I'm not going to go through this because it's the same exact thing that we talked about. In this case, I used the 3 and the 36, and I used the first term of 24. And I solved, and I got negative 9 was the difference, the common ratio. So to get each term, I could just subtract 9. Subtract 9, subtract 9, and subtract 9. Now, I do want to show you one different way of doing this. That way is fine. There is a different way. Let's say and this works best if you don't know. See, in this case, we do know our first term. But let's say you didn't know your first term, and you knew 2 other terms. The common ratio, not only can you use the arithmetic formula to get it, but we can use our slope. You know, we learned the other day, and we're going to review again how to use slope-intercept form. Well, another name for what you're adding or subtracting every time is the slope. Well, this is the slope formula. So technically, if I take any two y values and their corresponding x values, and I plug them into the slope formula, 16 minus 2, 1 minus 4, and I get 14 negative thirds. That actually lets you know that every time x goes by 1, you're losing 14 thirds. So this is just another way to do exactly what we did on the first couple slides. Either way works, but it's a way to fill in missing terms as long as you know it's an arithmetic sequence. And this is going to then help you do page 80 and 81, which is your homework.